Dear students and participants of the course on railway engineering, we are today going to discuss about some of the rolling stock like wheels, axles, locomotives and wagons which are used on Indian railways. If we look back in the previous lecture, we talked about the gauges, we talked about what type of gauges have been used across the world, what are the factors which are used in the selection of those gauges, the problems which have occurred and have been experienced when the multiple type of gauges have been used in a country like us. And then came the uniform gauge policy and what are the benefits which we have derived when we have started working with that policy and converting everything to the broad gauge. And finally, in that lecture we completed the lecture with the loading gauge and the construction gauge. Now today we will try to cover these aspects, the wheels and axles, the locomotive classification and the wagons. The coning of wheels will take up if there is a time being left for it. Now let us start with the wheels and axles combinations. We can see on this side, on the right hand side, one of such thing is being provided as being shown here. So there is a AAR classification. This AAR is an Association of American Railroads and they have given a classification of wheels and axles. And it classifies the locomotives based on the arrangement of the wheels and below that. Now what is the codification of the wheels? That is what we are going to look in some subsequent slides. The first codification is based on the carrying wheels. The wheels which have been defined as carrying wheels means they carries the weight of the locomotive, but they does not have the driving power. So they are simply wheels, and at the top of which we have constructed the body, and then the body is being filled either with the freight or there is a facility being provided for the passengers to sit down there. Now when we talk about these carrying wheels, they are codified by numbers and there are numbers like 1, 2, 3 so on. What does these numbers define? The number 1 defines that there is one set of carrying wheels. Number 2 says there is a 2 set of carrying wheels, 3 said there is a 3 set of carrying wheels and so on, it will go on. So it means if I talk about an axle and there is a wheel here, this is one set, but if we have another such axle being arranged alongside that, then it means it will be defined by 2, but if I go further and I put another one here, so that is going to be defined by 3 and then the 4 system can also be there. So this is a one type of an arrangement which can be there. Another one is related with the driving wheels. Now these driving wheels, they will carry the load, but at the same time they have a motor and with the help of which they will drive the whole of the locomotive. So that's a way it is going to work. Now how they are denoted? They are denoted by letters. Previously we talked about the numerals 1, 2, 3, 4 and so on. So here the letters are there, but then the use of these letters again we need to see carefully. There are two subgroups here. One is independently driving wheels, another one is coupled driving wheel. Independently driving wheels means there is a one set and this one set and there is another set also if suppose being provided at the back of it, they are not connected together. It means whatever the power is there on this particular first set, it is utilizing that and the second set is having its own power. In such cases what we do is we use these letters but suffix them with O. That's why we say it is AO, BO, CO, DO likewise. But when there is a coupled driving wheels, it means these two are being coupled together and the same driving motor is going to provide power to both of these sets. In that case they are coupled one and here the symbol which we are going to use is dash instead of O. So it will become A dash, B dash, C dash, D dash likewise. Now here are some examples being given. When you talk about the independent driving wheels, AO, this is one set of driving wheel on a bogie. A is for 1, B is for 2, C is for 3 and D is for 4. And because O is being attached here, as we talked previously, if you are talking about independently driving wheels, then this suffix O is going to be there. So, that is where AO, BO, CO and DO configurations can be possible. There are other configurations which can be there where the combinations will be talked about. Say we are talking about BO, BO. It means there is a locomotive with 2 bogies and each having 2 independently powered axles. B means 2 and O means independently conditioned. So, BO means there are 2 powered axles, but then there are 2 bogies because there is a dash in between. So, there is one bogie being provided here and there is another bogie being provided here. So, that is the way we are providing. Say if it is BO, BO and BO, that means 3 such bogies are going to be connected together. Okay, and when I am saying bogie, bogie does not mean I am talking about a wagon or a coach at the bottom. Now, this is a bogie which I am talking here. So, this combination is a bogie. Okay, so this is a set which is being provided at the bottom where the wheels are there. There may be a driving power which also being provided, and then this combination at top of that only the body will be placed so that the load will be carried. They say if we take an example of CO, then that means this is a locomotive with 2 bogies and each bogie is having 3 independently powered axles. So, likewise different such combinations can be there. In the case of coupled driving wheels on axles, if we look at, we said that we are going to provide this dash with that. So, it is B dash B dash. What does that mean? It indicates that the wheels or axles are coupled mechanically and the same motor is giving the power to all those axles which are being placed in the bogie. So, if we see on the other side that this is a coupled system being provided and this coupled system are getting the power from the same power unit, and that is how it will move. And say if we look at the figure which is being provided at the bottom here. So, there is a frame and before frame there are 2 bogies 1 and 2, and within that then what you found is that there are 2 sets and these 2 sets they are being coupled together. So, they are coupled together here with the jack shaft and same is on the other case. That means this is B dash with a hyphen in between. So, that is how we are providing the values. The another case can be a rigid frame locomotive. Here chassis is directly mounted on the wheels. Say if you take the example here, M is for the motor. So, this is a motor driven wheel which is being provided and there is a chassis at the top of it. So, there are 3 sets of such independent driving wheels, and because there are 3 sets of independent driving wheels, it comes out to be CO. Say if we look on the right hand side, what we found is there is a one combination here, there is another combination here and they are independent. So, if they are independent, then we will be talking about, because these are 2 sets. So, this is BO and this is BO. If they are having a driving conditions, if they are not having a driving conditions, then it will be, say they are independently carrying wheels. So, if they are independently carrying wheels, that means it is 2. Then you have the coupled system being provided here. So, if it is a coupled system, then it can be B dash, and then if again there are 2 sets being provided in the front and they are simply carrying one, then it can be again 2. So, that means the combinations can come up in different forms. It can be BO, BO, B dash 2, or it can be 2, 2, B dash 2, or likewise any different type of thing can happen. Another type of a system is a bogie type of a locomotive where wheels are first arranged into the bogie and then chassis is mounted on the top of the bogie. So, that is the way the arrangement is being done. But this allows higher flexibility and it is better when the train is going to traverse a curve also. Now, say the example is being given here, we have again a motor unit here and motor unit here, and there are 2 independent driving wheels conditions. So, it means this is also, this is BO and then another one is also BO, and that is how these 2 are being defined. Let us look at another example here. So, there is a frame, there are two bogies being provided, and then below those bogies what we have is the wheels 1, 2 and 3, 1, 2 and 3. Now, say this 1, 2, 3, and if I put it again 1, 2, 3, or say I can say 4, 5 and 6. So, this 1, 2, 3 is being governed here and 4, 5, 6 is being governed here. And suppose all these three are motor units. So, it will be motor, 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 and similarly on the side also it is motor, motor and motor. Then it becomes nothing but this is 3 sets. So, it is CO, and this is also 3 set, it is CO. If it is a motor carrying motor and motor carrying motor, in that case, because the first one is become independent now, so it will be single one. So, it will be A naught. Then carrying means they are defined by the numerals 1, 2, 3. So, there is only one set like that. So, 1 for it, and again there is a single axle wheel combination. So, A naught for that. So, it is A naught 1 A naught and is being repeated on the other side also as A naught 1 A naught. Suppose the third condition is that we have the first one as carrying, and then there are two subsequent 2 and 3 they are motor units. And similarly in the case of the next bogie there are 4 and 5 motor units, but 6 is a carrying one. So, in that case what happens, because this is a single one wheel which is carrying, so it remains 1 here, but then 2 and 3 or 4 and 5 they have become combined, they are motor motor. So, it becomes B0. So, BO, so 1 BO and BO1, that is the way it is going to be defined. Similarly, if it is motor motor carrying and carrying motor motor, it is motor motor means BO and then single one and then 1 BO. So, whatever the configurations are available, you can very easily make it out that how they are going to be designated for any of the locomotive or any of the bogie set which is being provided for wagons. Now, here we are talking about a coupled system. You can see that there is a coupling being provided here, and then there is a carrying one at the front and there is a carrying one at the back also. So, here there are 4 coupled systems 1, 2, 3, 4. So, that is where it is D dash, and there is one carrying in the front and one carrying at the back. So, it is 1 dash D dash hyphen 1. So, that is how this is defined. Now, if you see the other one, here there are 2 carryings, that means it is going to be started with 2. There are again 2 carryings, so it is going to end with 2. And then there are 4 motor units, but they are 4 motor units, they are not being coupled. So, when they are not being coupled, so it is DO. So, it is 2 dash DO dash 2. So, this is the way we can provide it, the nomenclature. This is another example. In this example, the additional thing which is coming up is this articulation coupling. Now, here there are 2 motor units in a bogie, in another case also there are 2 motor units in a bogie, it means they are BO and BO, but because this articulation coupling is there, so this is defined by a plus in the center and instead of dash. If this articulation coupling would not have been there, so it would have been defined as BO dash BO, but here in this case because the coupling is being provided, so we are going with BO plus BO. So, this is another variant. Now, if you look at the Indian Railways locomotives, there are different type of locomotives which have been used. We will be talking about these nomenclatures a bit afterwards, but what we can see is here that there is a WAG1 to WAG4, they are being given the wheel arrangement, axle arrangement as B dash B, whereas WAP5 as BO. There are a number of locomotives which are having a configuration of CO dash CO, means 3 and 3 independently driving wheels on WAM4, WAP1, WAP4, WAP7, WAG5, WAG6C, WAG7, WAG9, WCAM2, WCAM3, CAG1 and CM6. A 3 combination system is also available on WAG6A and WAG6B. So, these are the locomotives which are already in operation in the Indian Railways. Now, let us talk about the locomotive classification. Now, in the case of locomotive classification, the bases are three. First one is the gauge for which it is being manufactured. Second, what is the type of traction which is available? So now we do not talk about the steam locomotives, but we have the diesel locomotives still operating, and then we have the electric locomotives which can be working with AC and DC. So that is the traction we are talking here. And type of the load to be carried, say we are carrying passengers or they are carrying freight. So accordingly the nomenclatures are also there. There may be possibility the same locomotive can also be used for carrying passenger as well as freight. Then the another type of indicator will be there. Usually in all of these cases we are using an alphabet to indicate a situation. That means it is going to be a combination of three, as you have seen there: WAG, WAP, WAM. So they are all three. So they all are governed here. WAG, if I say, that means the first one is going to the gauge, the second one is going to the traction, and the third one is going to the type of the load which is going to be carried. Now, based on the gauge, if we talk, for broad gauge, the W is being used, for meter gauge Y, and for narrow gauge Z is being used. So these are the three alphabets: W, Y, and Z. Now, because now we are converting to the totally broad gauge, and after some time we may find that we are having almost 100% as broad gauge, then in that case everything will be starting with W for the locomotives. Based on traction, for diesel it is D, for AC electric it is A, and for DC it is C. And there is a combination of CA, means there is a possibility if on a particular locomotive both of the tractions are being provided, then it is defined as CA, first DC and then AC. So previously we had one more code which were having 4 letters, and that 4 letters will arise because of this combination. Now, based on the type of the load, for passengers it is P, for goods it is G, but if it is a mixed condition, that means it can take up, it can be used for passengers and goods, then this is going to be M. There can be some locomotives which are only used for the shuttling or shunting conditions, then they are provided with the code S. If it is a multiple unit, then for multiple units we use U as a code. So here we can see there is a WDG. Now what is WDG? So you have to identify that. The first one is related with the gauge. So if it is W, it is broad gauge. If it is D, the second one is for traction. So D was for diesel, and G is for goods. So it means these two locomotives which have been shown here, they are basically useful for transporting the goods, and they are operated on diesel, and they will be used on a broad gauge track. If it is WDP, then it means it is again for a broad gauge, being using diesel as a traction, but is only used for those trains which are carrying passengers, and that is where the P is being provided here. The locomotives which are there in service, they have been defined here. Now, one thing which we have not discussed so far is after those three, there is another number which is being given. That number defines the series. If I say WDP4, it is a fourth series of the development of the WDP locomotives. So we have things which are available in use at the moment in Indian Railways. They are not all the locomotives which have been manufactured. There are certain locomotives which have been now taken out of the service. So what we are left in the diesel is WDM3A, WDM3D, WDP1, WDP3A, WDP4. In the case of say the goods transportation, we have WDG2 or 3A, then we have 4, 4G, 5 and 6. If we talk about the electric traction, then there are a number of such locomotives available like WAG 5 series, 6B and C series, 7 series, 9H or I series, then 10 series, 11 series, 12 series, they are there. For passengers it is 1 is there, 4 is there, that means 2, 3, they are out of system now. 5 is there, 6 is out of system, 7 is there. Then CAM we did talk about it. As soon as CA comes, it means it has both tractions as DC and AC. So they have a 2, 3 there, and WCAG1 is there. WAU1, that is a multiple unit system, 2, 3 and 4 are there. And for shuttling, we have WDS6 in operation. And these are related for the broad gauge. Now, if you look at the locomotives and weight is going to be distributed, the total weight of locomotive, if suppose it is 112.8 tons. Now, this is one example. Depending on the different type of locomotives, these weights are going to be different. Now, if you have two bogies and each bogie is having 23 tons, then the weight of two bogies is going to be 46 ton. Weight which is to be borne by the bogies is now 112.8 minus 46. It means they can carry a load of 66.8 tons. And if you are talking two bogies, for per bogie it comes out to be 33.4 tons. Now, when we talk about the system which is provided at the bottom, which is going to take a load, then in that case, the weight which is borne by the center pivot is 60% of this load which comes on one bogie, and the weight which is borne by each side of the barrier. So, it means 20% on one side and 20 on the other side of the total load, and that is how the total load gets distributed to the wheels. So, this is how the system works here. Now, let us talk about the locomotives comparison. Now, here the different locomotives have been talked about. So, we have a first set of WDM2 or WDM3A. The another set is WDG2 and WDG3A. So, first one is mixed one, can be used for passengers as well as freight. Second one is only for the goods because it is related with G. WDP3A, again this is the passenger one. Fourth one is again for the goods because it is having a code G, and then the fifth one is again a passenger one. All are W starting, that means they all are for broad gauge, and the second code is D, that means they are driven by diesel. So, diesel traction is there. Comparisons which have been looked here, they have been looked on 6 counts. The first count is the bogie, the second one is what is the tractive effort, axle load is the another one, gear ratio, pinion to bull gear, that is another one, the what is the maximum speed at which it can take the train, and the weight transfer to wheels, how much the load is getting transferred. In the previous example, we did talk about the 60% comes in the center and 20% goes to the either side. So, similarly, is it same or they are different? That is what we are looking here. So, if we talk about the bogie and we move from one to the another, what we found is that there is a cast steel fabricated systems, the HTSC systems or the HTSC fabricated systems which have been used for the manufacturing of those bogies. Then in the case of tractive effort, this tractive effort is varying, and it is varying from 27.55 tons to as high as 53 tons in the case of WDG4. So, it means it is being developed for carrying very heavy loads. In the case of passengers, we see it is 32.8 tons in this side and 27.44, but if it is a mixed one, then 30.4 tons is what is being carried. Axle load which comes on a particular axle, what we can found is it is changing from 18.8 tons to 21 tons. It can be a bit more also, it all again depends on what type of the locomotive we are going to talk here. So, that is a variation which you will find. The gear ratios are being defined, and the gear ratios again are different, like 18 to 65, 18 to 74, 22 to 61, then 1790 or 1777. Maximum speeds, in the case of the mixed one, it is going to 120, but if you look at this WDP3A, so that has been manufactured for a speed of as high as 160 kilometers per hour. If we talk about WDP4, there are two sets, 160 and 135 kilometers per hour. Weight transfers to wheel, The first case is the same one which we have discussed in the previous slide. In the second one, it says there are 4 numbers of side bearers at 25% each. So 25 into 4 means 100 goes this way. In the case of WDG4, again it is 4 numbers side bearers, and then for WDP4 also the same is being provided. So that's a arrangement which is there. 25% of the load is coming on each of the side bearings where the loads is going to be transferred. There is another comparison here for WAP 5, 7 and WAG 9H. They are the latest ones which have been manufactured, which have been in use. When we say A, it means we are talking now about the electric traction, and P is for passenger and G is for goods. All these locomotives, they are in use for the broad gauge. Again, if we see the capacity, in the case of capacity, the horsepower is being given, and what we found is that for WAP7 and WAG9H, they have been developed for a very heavy horsepower of 6000. The weight of locomotive also in these two cases, it is going to 123 tons and 132 tons as compared to 78 tons for WAP5. It is much lighter in weight. Bogies, here you can see BO combination. So that means there are 2 independently driven wheels sets, and then another bogie is having the same thing. But in the case of WAP7, WAG9H, we have CU and CU. That means 3 such independently driven wheel axle combinations are there per bogie. Axle loads, there are 19.5 tons, 20.5 tons and 21.5 tons. They are increasing as we move from these developments. Starting tractive effort is 26.3 tons, 32.88 tons and 51 tons. Now this starting tractive effort means there are a number of resistances which are going to be there, and when the locomotive starts from 0, then it has to overcome all those resistances. So that's where it may require more power at that point of a time, but as soon as it comes into the overall operational system, then the requirement of power will be different. And we will be talking about these resistances which are offered by the tracks in the subsequent lectures. Then the effort in terms of the maximum speed here it is coming in a WAP5, but as we are going to the higher sides and say we are talking about the higher load of the locomotive, the speeds are reducing. So it is coming to only 90 kilometers per hour in that case. So that's a comparison of locomotives which are electrically driven. Now similarly, there can be various other locomotives also, and if required, then those particular comparisons can also be made. But I have given you as an example that what are the various changes in the values which may be there and which you need to understand. And we will be talking about this weight of locomotive, we will be talking about axle load, we will be talking about this tractive effort. When we talk about the resistances, when we are talking about the stresses which are going to be induced in the different components of the track. And this maximum speed we will be considering when we will go into the geometric design aspects. There we will talk about the maximum speed, we will talk about the permissible speeds also. So now there is another set related to wagons, and these wagons they can be of 2 types which are in use on Indian railways. One which have been manufactured by ICF, that is Integral Coach Factory, and they are being defined by that code as ICF coaches. Another one is which has been taken from outside, and this is Linke Hoffman Bush coaches and being defined by their first alphabet as LHB coaches. And these ICF coaches, if we talk, majorly these ICF coaches have been used on Indian railways, but once the second set of coaches have come, they are having many benefits, and looking at those benefits, and slowly the Indian Railways has started changing those coaches to LHB coaches. So these ICF coaches, they have been built at ICF Perambur, Chennai. They are going to be scrapped by 2030, and if you remember that we talked about the Indian Rail plan of 2030, so that's what it is talking about. and they are still in use on the Garib Rath. So, we can see that there are different color codes coaches are there. So, if we talk about the first one, which was a brig red livery, so it was there from 55 to 1990, and after 1990 then it has been taken out. If we talk about the blue one, then it is started in 1990, still it is in use, and Utkrisht type of livery which is started from 2008 and it is still going on. So, there are different such color codes which were used so as to identify that these are different coaches which started at some point of a time. But if we are talking about these ICF coaches as being defined here, that we are going to scrap them by 2030 and we will be shifting finally to the LHB type of coaches. So, here are some other ICF coaches which have been shown. You can see that this is of Rajdhani, which started in 69, but then this was stopped in 16. Shatabdi, it was started 88, then it stopped in 2019. Garib Rath, which is going on, started in 2006. Duranto started in 2009, when 2020 it has again been stopped. So, there are different such photographs which have been given to you here to understand the actual photographs at the platform or on the track which you might have seen. So, I will be stopping here. There are few more things which needs to be discussed about the wagons, specifically the LHB wagons. So, what we discussed today was the wheel and axle arrangement on locomotives and coaches, how we classify them, how the locomotives are being classified, what are the comparisons across the different types of locomotives which are there, and then we started discussion on wagons and some comparison we are going to do in the next lecture. Till then, thank you and bye.